Generally, I use the word extension, but stretch is, yeah.
Yeah.
So with both of these, you're taking a dough piece after mixing and looking at its characteristics. With the alveograph, you blow the bubble. With extensograph, you stretch the cylinder. But you're looking at extensibility, how far that dough piece will stretch or expand before it's ruptured, and resistance to extension, how tight that dough is, kind of a strength kind of thing. With alveograph, there's a couple other terms. W is used to indicate the total work, so generally the higher the W, the stronger the flour is a general rule, besides looking at extensibility and resistance to extension. So those general things about it.
Look at P/L, G,
Yeah.
and all that good stuff.
This P and, so in extensograph we call it extensibility and resistance, E and R. So with extensograph you measure E and R, which are extensibility and resistance. And the similar term with the alveograph, the L or length gives you the extensibility, and the P gives you the resistance. So if those, they're called different letters, but they're looking at the same kinds of things.
He's what?
P would be the resistance, the pressure that it takes to blow the bubble, like blowing up a balloon. The tighter it is, the more pressure it takes to get that balloon to blow. So we're just blowing a balloon, but it happens to be a gluten dough balloon. Spread test is the one where we do with fermenting dough. Where you're measuring the ratio of the width to the height. And the cookie spread, you're using the same ratio of the baked cookie, the width to the height, to get an indication of the flow properties there. But it's a baked cookie, not a fermenting dough. But that spread ratio is how much does it spread? How wide does it get? And consistometer and Brookfield are looking at flow characteristics or viscosity. But it's a fluid viscosity, so it's a batter. You could use either one to test your cake batters in lab to make sure that you have the right flow properties for that batter. On the consistometer, you measure in either seconds or centimeters. And the Brookfield you measure in centipoise. So you could do a flour water slurry on that batter, with either instrument, or you could make a full batter and test it.
What is a centipoise?
Centipoise is a scientific unit of viscosity. It's used for measuring like how thick an oil is. So it's just another unit. Actually, it's 1/100th of a poise. It doesn't have to define poise. And SRC, or solvent retention capacity, uses up to 4 different solvents. And how do I want to word this?
That's sugar, or water, sugar.
Indicates functionality without actually measuring the chemical components.
Water, sucrose.
So it correlates or relates to the chemical components of the flour, like the protein or the damaged starch or the ribinoxyland. You're not really measuring those. So the important part is that it indicates functionality of the flour.
What exactly is measured?
You measure how much solvent is retained by the flour. So you take the flour, and let's say you're doing the 50% sucrose. So you have this liquid that's equal weights of water and sugar.
Yeah.
Okay, you take a certain amount of that, weigh it with, add it to a certain amount of flour, shake it, let it sit there so that the flour is going to hydrate, kind of like in your sedimentation flask, you know, the flour hydrates. But then you centrifuge that system, decant or pour off the liquid that's free, and weigh the sample so you know how much solvent or liquid that flour retained or held onto. So it's always going to weigh more than the dry flour, but how much does it retain? Equal weight of the flour, half as much?
You can try 4 different solvents at one time?
No, you have to have 4 different samples.
So you've got water, sugar, and flour in there, or just
Yeah, flour plus whatever the solvent is.
like 5% sodium carbonate?
Yeah, so it'd be flour plus solution of 5% sodium carbonate. Shake those together, let it set, centrifuge it, pour off the liquid, weigh it. How much did it hold on to?
With no water on that test.
Well, the water is the 5% carbonate is 5% in water.
Okay.
So they're all water-based.
Okay.
So are there 4 main solvents that are used with that?
Yes, and a lot of people are just using 2 or 3 of them, not all 4.
Do we need to be familiar with the 4 different solvents?
No, you don't have to memorize
Is there
those.
an ACC method
It is an ACC method.
as far as how much sample and amount
Yeah,
to dissolve?
yeah. Yeah, and I think I gave you the reference number.
Water, sucrose, sodium carbonate, and lactic acid.
Yeah,
Those are
but you
four.
don't have to know those.
How much water is in that test?
I can't remember. It's in my notes, but I don't remember how much, what the weight of the solvent is.
That's a
I
good
haven't run
thing.
it for a long time.
Okay.
I think those are the only ones that we haven't done or talked about in lab. So the rest of them, I'm not going to say you shouldn't know, but they should be easier because you've done moisture, flour moisture. We've talked about ash. You didn't do it, but we talked about it. What is ash measuring?
Mineral content.
Non-endosperm material.
Minerals, which are inorganic,
Inorganic.
inorganic minerals, indicates what?
Non-endosperm material.
A non-endosperm. What part of the kernel has the most mineral content?
The alurone.
The alurone, which right now we remove with the bran, so we use it to indicate how much bran, non-endosperm material we have in there. Because the endosperm has very low mineral content. That's done with the muffle furnace. So you heat it. This will also help you for your, there's some overlap between the score quiz tomorrow and the exam on Monday, because on the score quiz tomorrow, it includes the labs that had moisture, two-stage moisture, ash, protein, you know, so this is kind of a review for that too. Doesn't hurt. Protein, standard methods for measuring protein are
The combustion.
Keldol or combustion. What is it measuring?
Nitrogen.
Not crude protein.
Measures the nitrogen, which indicates total protein, not just gluten-forming protein.
Or crude protein.
So total protein or technically crude protein, you're right. But it's not just the mineral, or just not just gluten.
5.7.
Yeah, that's a good, certainly no. 5.7 is what? Okay. Factor for wheat. 6.25 is a factor for,
This factor is for the
either one. Anything that's measuring, because we take this factor times the nitrogen content. So it doesn't matter if you're using Keldol or combustion or even NIR, we're taking what it's measuring as nitrogen times that factor to give us how much protein. And the reason that wheat has a smaller factor is all proteins have different amino acids making them up. It's kind of like carbohydrates have different sugars making them up. So the amino acids that make up wheat proteins have more nitrogen per unit than the others, so we multiply it by a smaller number to get the protein that's there.
So you're multiplying by the number.
You
of
take the nitrogen
atoms,
times that.
Number of nitrogen atoms.
Number of nitrogen that you've counted, measured, times that factor.
You just listed Keldol and combustion.
Mm-hmm.
Why is the NIR listed as?
It's not a standard method. The NIR is it's not a reference method. So you run NIR, but you have to
You have to base it off of one of
base
those.
it on a standard.
And when you multiply those, what does it give you?
It gives you percent. When you multiply the nitrogen times the correct factor, it gives you the percent protein.
Yeah, I'm a bit lost.
Okay?
You said that wheat has a smaller factor because the amino acids that make up wheat, there's so many of them?
No, because there's more nitrogen. Not every amino acid has at least one nitrogen molecule in it. But it just happens that a lot of the amino acids that make up wheat proteins have more than one nitrogen per amino acid. So we have a higher concentration of nitrogen in the protein, so we have to multiply it by a smaller factor. What?
We have to remember everything you
No.
said. 5.7.
Or,
That's what you need to remember.
or it'll come out to be like 27% protein.
Yeah, you're going to
and
end up
you
with
really
way
don't-
more protein
And
than
you really don't have.
Okay, I haven't done that yet, but okay. We started here on page 2. So these are all analytical things, right? These are straight analytical methods. These are looking at the rheological characteristics, the functionality characteristics of the specification. These are all chemical analysis. Or analytical.
Ash, protein, or
Ash, protein, moisture, those are all analytical. They're not talking about the functionality directly. They're measuring components.
First one is what?
First one is what?
These are all functional here. These are just straight analytical.
Functional test.
Functional or really
Rheological.
radiological? Is that what radiological means?
Rheology is the study of stress and strain. How does a substance react when you put pressure on it? How does that dough feel? How does the batter flow? That's really what rheology is. So So all of these things are trying to measure how that flour is behaving when you get it into a system.
So would the texture analyzer be a real?
Texture analyzer would be finished product, rheological, yeah, because you're looking for finished product. Measuring alpha amylase, you should know, that should be pretty much a review for you. What test do we use to measure alpha amylase? Falling number.
A myelograft, an RVA.
Okay, and probably these two are certainly the most common, and falling number is the most common. So if we're looking at optimum for a yeast leaven product, what kind of range would I look for on falling number?
200 to 300 seconds.
Okay, I'll go a little tighter, but I'll say 250 plus or minus 25 probably, but you might set a little. But in that ballpark anyway of seconds. And a myelograft,
5 to 6.
I'll go a little wider.
4 to 6.
400 to 600 BU, Brabender units. So if I have too much alpha amylase, how am I going to recognize that from this data?
It's less, if you have too much, it's less than 4.
Okay, if I have too much alpha amylase, that means the system is very thin. So either that would fall faster or it's going to be less viscous.
Smaller number.
Smaller number is too much alpha amylase.
With less viscous.
Yep. Because remember, alpha amylase is the liquefying enzyme. So if it's thinner, it's excess alpha. So on the other hand then, if it's higher number, it's thicker, less alpha amylase. These work for measuring cereal or bacterial, but we don't put bacterial into a flour. Some of you forgot that minor detail on your homework today.
Yes.
But now you remember.
Wasn't it?
That might be important to remember by Monday.
We don't put bacterial in, wasn't it?
We don't put bacterial alpha amylase in flour.
No, that's why I got that wrong.
That's why you got it wrong. Put that down. You had
Not-
quite a bit of company.
You can at the bakery.
You can at the bakery. You cannot. It's at the mill. Because what we're talking about here is your flour specification. So what's coming to you from the mill.
Question. Oh man, I got hit hard.
Nutritional, we talk about enrichment. It's yes or no. You add it or not. Phrenograph, mixograph. Talking about mixing characteristics. Right? You see why a lot of people call the rheology lab the O-graph lab? Almost everything seems to be something O-graph. So here we're talking about mixing characteristics, which include what? What information do you get from phrenograph?
Peak time.
Absorption, peak time,
And breakdown.
okay, and something about strength or tolerance, which could be MTI, mixing tolerance index, it could be stability, it could be time to break down, but we're talking about strength. So in the mixing. So the alveograph and extensograph are looking at after mixing. Phrenograph and mixograph are looking at during mixing. So they're different.
Absorption, what? And then
Absorption, peak time or mix time, and something about strength.
All 5 of these tests would be rheological.
All these are rheological, yes. Functional or rheological tests, yes.
Do we need our little ruler? Our little stone?
Yeah, you won't need a protractor, no.
Okay.
No.
Thank God for that.
And the phrenograph was talking the 500 line.
you're not going to go into these details that if it gets off the graph, you got to put extra weight and all that.
No.
stuff.
The Green Graph, I'm targeting 500, right? 500 line.
Korean graph needs to be centered on the 500 line. Sedimentation, what are we measuring with that?
quality and quantity of protein.
Okay,
Quality.
quality and quantity of predominantly gluten-forming proteins, but of proteins.
Sorry. Gluten quantity.
So we get both. It's primarily quality, but quantity has a big influence there too. Gluten washing, whether you're doing
The gluten index.
either by machine or by hand. What kind of information are you trying to get? Okay, the gluten forming only. So we can get the percentages that give us something about the quantity of protein that's in there. And by the feel or by the centrifuge to get gluten index, we can get quality. So the percent wet or percent dry give us quantity. And the feel or gluten index are looking at the quality. And no one test is perfect, but we get little bits and pieces from different things.
The sedimentation test, it judges quality and quantity because it really doesn't distinguish between the two.
Right.
Yes. We need to know the formulas for wet, dry, and GM.
You don't need to know the formulas for calculating these for the lecture exam, no.
Are there any formulas you need to make sure
Not using the calculator.
I
Request.
don't think you need a calculator at all for the lecture exam.
So there's no formula.
The lab tomorrow, yeah, but the lecture exam, no.
Jesus.
Flower problems will be on the lab score quiz.
Tomorrow?
Oh, there's a high probability.
Let's say yes. Let's say yes.
There will be flower problems for several more score classes. Not as many tomorrow because there's lots of other things to cover tomorrow.
Hallelujah.
Can we go over a couple of those
You got the
problems?
centrifuge thing?
Yeah, gluten index is the centrifuge test.
Can we go over a couple of those money problems?
Okay, when we get done with this.
Money is the root of all evil.
I want to back up to the very first page of notes on this section. We're talking about flour quality kind of in general. We're looking at all these tests that are measuring flour quality. But what determines the flour quality? There's two major things.
And the genetics.
Okay, so we have
GNU.
things that I'm calling inherent because they're inherited. I want to make sure I spell it right.
General election.
Which means they're inherited or they're from, definitely from the wheat. Even though we're talking about flour quality, there's some things that the wheat determines. And there, yeah, we talked about genetics, which is the G, environment, which is the E, and the G by E. And these two are about 70% of the variation. What do I mean? What's included in environment?
Soil type.
Okay, so
Rain,
soil,
rain, food
rain,
supply.
sunshine,
Fertilizer.
cold, snow, fertilizer, I mean all kinds. So it's farming practices and nature,
Insects.
kind of both.
Farming practices.
And when you mean 70% of variation, and you only bracket environment and G times E,
Uh-huh.
does that mean that genetics alone is 30%?
Genetics alone is probably about 30%. So by specifying, some bakeries are now specifying that I want my flour to only be from these varieties of wheat. And that's going to control 30% of the variation between years. But you're still going to have, even using the same varieties of wheat from year to year, you're still not going to have exactly the same flour from year to year.
So to me, genetics and environment are mutually exclusive. And that G
It was
and
mutually
E is
This is a statistical interaction between genetics and environment. We can't blame it on one or the other.
G&E is 70%.
Yeah. They're combined of these two. So what that's saying again is that even if you use exactly the same varieties of wheat, you're going to have variation because we cannot control Mother Nature. So it's back to life. Okay, so the wheat quality, what's inherited in the wheat, or what the mill gets with the wheat. So the millers try to find the best wheat to give you the flour you want. It's not always there. But then there is certainly control by the mill, which is why some of you like flour from one mill versus another, because then you get some actual variations of the flour. So that's what the mill does. It's how the mill treats the wheat. So that would be such things as, making sure they get it clean, how do they blend it, how do they temper it, what sieves do they use, all those things we talked about in milling. So it's actually what the mill does. So flour quality is determined by both. The reason I want to re-emphasize this is, not just for the test, but for you all as bakers to remember that the mills are going to try to do the best job they can because they want to keep your business. But there are some things that are beyond their control. So. Okay.
Cleaning, tempering, flow,
Yada, yada, yada.
That's actual.
Aging, when we talk about sweat,
Sweat
He's
blood,
breathing. Respiration.
not perspiration.
not perspiration.
Respiration, not perspiration.
So it's technically age-related, biological changes, which again means we don't have a whole lot of control for that. And remember that the wheat and the flour sweat. So the longer the wheat has been since harvest, the more rapidly the flour will mature. And it doesn't matter if it's chlorinated or not if you're using soft wheat flour. Chlorination may speed up the process. It does not completely replace it. Chemical oxidants are in there to try to help stabilize it, but we can't do exactly what Mother Nature did.
So sweat has nothing to do with moisture
No.
condensing on the
No.
outside. It's just the
No,
fact.
moisture condensing on the outside is mold growth and insect growth.
Yeah.
Yeah. No, this is just under the dry condition with air, being exposed to the air. There's some changes that happen in the wheat and in the flour.
So natural aging.
Natural aging.
That's why it's respiration, not actual perspiration.
Yeah.
So
It's a
they
natural aging
They
process.
just decided to use the term sweat because.
Yeah, I don't know. Somebody picked it 100 years ago.
All right.
The results of this are what? What changes occur?
Mellowing.
Mellowing in the protein.
When drunk Germans come over there.
I'm not sure mellowing.
You know the drunk Germans people
Yeah,
don't know how to
so
fix
we,
it.
it's really, again, mellowing to a baker generally means what? If the flour is mellow,
It decreases mix.
It decreases the protein
it's,
strength.
it's a little weaker. And really what's happening with this is we're getting maturing,
Increased protein strength?
which is usually strength. So I wouldn't really say, but it happens in cake flours too, and we don't think of cake flours as being strong, but it's certainly with age that cake flour will maintain its volume better. So there really is more of a strengthening effect over time. Yes, Alex?
No, I'll say it's nothing.
Okay, and the second thing that it does is it does cause some bleaching. So it causes whitening of the flour. And that's primarily when the flour sweats. You get it maybe marginal when the wheat, but it's the maturing and strengthening change, hard or soft wheat, doesn't matter, and it's wheat and flour. So these are both wheat and flour. The bleaching is more from the flour.
Is that from enzymes that are in the flour? Or is it a chemical reaction, the oxidation?
Both. It's a little enzymatic. Primarily, it is just an oxidation from the air reacting with it. So those are two things that naturally occur. So with cakes, we don't usually add anything to the flour to try to help it. But with breads, that's one reason we add chemical oxidants, is try to help stabilize this, the maturing. So the mill can add the oxidants, or you can add oxidants at the bakery, either way, or sometimes both. So flour treatments. And these are optional, remember. That's a shorthand for optional, OPT, optional flour treatments. We can add some kind of oxidant. Again, that'd be primarily in a hard wheat flour. We generally don't add chemical oxidants to soft wheat. And again, it varies depending on the law of the country what could be included, but oxidants, which kind of replaces, or the idea was to replace what Mother Nature did in the sweating. It doesn't exactly do that, but it helps relieve some of the stress. You can add some bleaching agents. It helps if your flour doesn't sweat. You use your flour within weeks of being milled instead of weeks or months instead. You use it within days instead of having it sit around for weeks or months.
And you get benzoyl peroxide.
And yeah, the two most common bleaching agents,
Chlorine and
benzoyl peroxide and chlorine gas. What's the difference? They both bleach.
Benzoyl peroxide goes in hard wheat.
Okay, benzoyl peroxide only bleaches. Doesn't do anything else. And no matter what Jeff Ward says, I don't think it helps with acne when you eat it. It will have reacted already in the flour, therefore it doesn't get into that teenager system. Chlorine gas, bleaches. What else does it do?
Weakens protein
Hey,
and strengthens starch.
It does both.
yep. And by strengthening the starch, it causes an increase in viscosity, and yet you can add more water and still get that increase in viscosity. So, and you get a pH drop, lower pH, which is an easy way to measure how the bleaching was done, measure the pH. So when you're unknown flours, if you think you have cake flour, I'd be looking at running pH and TTAs. The pH itself isn't what makes the changes, it's just a marker or an indicator.
Oh, close.
And so we got those two that are replacing what Mother Nature does, or at least kind of replacing what Mother Nature does. And then there's two others that the mill can do. They can malt, and they can enrich
Wow.
the flour. These are optional flour treatments.
How do they use chlorine in hard wheat? Or
Very rarely would you put chlorine in a hard wheat flour. There are a few. I used to say no, but of course you should never say never, because there are a few products where they want some chlorinated. Probably not using 100% chlorinated hard wheat flour, but put a little bit in.
Like what?
I know of a couple specialty breads that are using it in some sweet doughs, but it's very rare. Very rare. Brandon?
The most common malting, is that with barley?
Yes. barley flour is the most common, and what kind of malt is that, or what kind of alpha amylase would that be?
Cereal.
And the other common one is
And fungal is pure.
fungal is more pure, much more pure.
And
But
It's not 100% pure.
bacterial is the most.
Bacterial is more pure, bacterial is more heat stable, but
Yes, it
you
is.
have to add that at the bakery, not at the mill. We're talking about flour treatments.
Oh yeah, you got it.
Flour treatments.
No, I just didn't read the question enough, I guess.
Apparently several people didn't read the question. And with the enrichment, if you elect to enrich, you don't really get to choose what you enrich with or how much. If it's enriched, it's a standard enrichment, depending on the laws of the country the product's being sold in.
Calcium is
So
optional.
you can't put a little bit in and call it enriched, and somebody else put in more and call it. I mean, there are standards.
You try to memorize all of them?
What is an enrichment? Just in general, not the individual entities, but a more general classification would be,
Replacing what?
Riboflavin, thiamine.
okay, riboflavin, flavin, those are what?
Those are enriched.
And vitamins.
Minerals. Vitamins.
And minerals.
Calcium is optional. And folic acid.
And usually we say minerals, although usually we just add one, which is iron, but calcium is an option, so.
Folic
Calcium
acid
is optional.
birth defects in
Folic
men's
acid is a
brains.
vitamin.
Okay, from men's brains.
What's the difference between vitamins and minerals?
Minerals are naturally occurring. No.
Minerals are on the periodic table.
Yeah, that's what it is.
Well, yeah, vitamins aren't on the periodic table. Minerals are elements. They're on the periodic table. That's an easy way out. Double.
Are you suggesting that
Or are you suggesting that
That oxidants are optional? Yes.
you are saying that I can produce a flour?
oxidants are optional?
Adding oxidants at all.
But the baker has a choice of asking the mill to add the oxidant, or they can get it untreated and add the oxidant themselves. So it's an optional thing in your flour. You're buying flour, you can get just flour, or you can get flour plus oxidants, flour plus bleaching, any or all of these. Any combination is possible, again, depending on the laws of the country in which the product is being sold, made and sold. Other questions? That's a pretty good.
Good review. All right.
Oh, but we're not
I
done.
I wrote the exam
With
today.
what we have, we should have at least 80 on that exam. What's on
So
board.
when you're
Yeah, how much gluten is in flour? That's not on this test, but you'll see it on the final.
All right.
none, if when you're malting and you add malt, barley malt, that's actually sugar from barley.
No, it's ground up. He's asking what is barley flour. If you're adding malted barley, what they do is they take the barley kernel, the barley seed, allow it to start germinating or sprouting. They stop it partway through, get it to start, so the enzymes are turned on, but they don't go so far to completely destroy the seed. Dry it very carefully so they don't kill the enzymes. Grind it up, and that's what you get.
Just for the addition of alpha and alpha.
We're adding it for
amylase.
alpha amylase, and we get every other enzyme that's there.
Okay, right. That's what you said. It's a double methylated source.
Yeah.
Okay.
Sometimes that's good, and sometimes it's not.
So they let it start to germinate, then they stop it. How do they? By drying it out.
Yeah. By reducing the moisture carefully so they don't burn. They
Just
can't
enough
get
to
too
where
much
the
heat.
enzymes can stay